5-person developer team, and we have a source code license and tend to be a little bit on the edgier side of what's coming out of Unity. So we were doing, what are they calling them, asset bundles? We were using asset bundles before they were called asset bundles. It was fun going and rewriting all of our code because they changed the name of the object because it hadn't been released publicly yet. So yeah, we've been using a lot of the Unity features since a lot of them became public, and we've come up with some of our own issues and our own solutions to writing a large-scale project. The first question is why bother writing reusable code? So the first one's a little bit obvious. Lower cost, reusing code saves you time the next time you need to use it. The second one, in theory, works, right? So if you are reusing code that you tested the first time, then it's battle tested the second time, and you don't have to test that area. You're only testing the areas that you've changed, not the areas that you haven't changed. And then for a lot of people, the question is, well, why bother writing? Why use this technique if I'm working by myself, right? I'm going to remember all my stuff. And the thing that I've been talking about for years is that when you're working by yourself, you 6 months later is the same thing as another developer right now. So if you can remember what you had for breakfast yesterday, most of us can't. So if you think about this code that you're writing today, a week from now, you're not going to remember what you were doing. And so the idea is that you want to use these practices all the time, not just when you're working with a team, because 6 months from now, you're going to want to modify this thing, or someone's going to say, hey, can you do something just like that last project, but with these changes? And you have to go back into your code and go, what the hell was I thinking? You know, function names like run this once and only once, right? You know, had some clear meaning when you wrote that the first time, but, 6 months later, you sit there going, I'm sure there was a reason why I named it that, but that's not really quite explicit enough. So there are 4 main strategies that we use to write reusable code. One is decoupling wherever possible, so take your classes and break them apart and make them less reliant on each other. The other major one, which Joe actually touched on last year at Unite, for those of you who were there, is the fact that you can have public game object and component references in the inspector and be able to drag game objects onto other scripts as references is great for the first week you're using Unity. It's really cool that you can do that, and it gets you going very, very quickly. Once you start building complex projects, though, that actually becomes really problematic. Among other things, there's no way to remember exactly what game object you needed. There's lots of information that dragging that on there doesn't really contain, like why did you drag that particular one? If something gets a little tweaked in your asset or your prefab and all of a sudden that's broken, you've got a null reference exception, you don't know why, you don't know where, you don't know when. So really, after sort of your first week of Unity, it's time to stop using public game object references and public component references. And then the other strategy is that compile time errors are always better than runtime errors. And this is just a general strategy with coding. It's a particular strategy with web coding. To give Unity a lot of slack, Flash didn't have a functioning runtime debugger until version 8, right? Before that, you could get it working in theory, but no one actually could manage it in practice. So your goal is to actually take as many of your errors that might happen and push them into the compile time process. So as soon as you hit compile, you see what's going on, as opposed to playing it and having a browser crash and getting complaints from potential users. And at that point, you're sort of beyond the moment where you're going to have any useful information about what's going on. And then the last one is using the event model. And that's not a, the event model is not an inherent property of any particular language. It's just a programming model that we've adopted for various reasons. And I'm going to go into details a little bit more. There we go. Decoupling your code. I got a little repetitive here for good reason. Smaller classes, smaller classes, smaller classes, smaller classes. Lots of small classes are easy to reuse. Big classes are harder to reuse. It's almost a perfect relationship. The bigger the class is, the likelihood that you can ever reuse it diminishes linearly, if not exponentially. And then the other approach is interfaces. I don't know how many of you have enough coding experience to know what an interface is. I'll let you look it up if you have. If you haven't, I'll let you look it up if you haven't. But the general idea of an interface is that rather than requiring a specific class, you require a class that can fulfill certain requirements. And then anything that wants to fulfill those requirements can step in. That makes things reusable in 2 ways. First of all, it lets you expand your code beyond your current what you can think of implementing right now. So, for instance, we are in the process of hooking up SVN as an asset repository to Unity using all our great new editor classes. And SVN is really just step one. We'd eventually like to be able to hook up any asset repository that might come along. So rather than specifically implementing an SVN class, there's an interface, which is a repository interface that SVN implements, and then we can have a Perforce interface and other interfaces as they come up. And that basically lets you reuse this half of the code. So now you've got the decoupling going on. The part on this side of the interface you get to keep. The part on this side of the interface you can rewrite. And that's sort of really basic decoupling. And the last one is private members. So again, the inspector is a really powerful tool in that anything that's public, anyone can come along and tweak. But it's a very abusable approach to writing your code where everything becomes public and anything you want to know about any other class is just available and other classes just start grabbing variables sort of willy-nilly. You want to sort of make things private by default and expose things publicly only if it really needs to be known. You really want to maintain that level of encapsulation for those of you who know the technological term. But this is really basic decoupling. Loosely coupled code is a really, really good thing. It's really our mantra over at Hangout. Everything is loosely coupled. We don't have strict contracts between classes. We don't have strict contracts between the server and the client. The real goal is that as soon as any technology or any framework no longer suits us, it's gone and we replace it, and all the other parts need not know that that change has happened. It's what's made us be as nimble as we are and be able to handle the growth that we've been able to handle in terms of what our application needs to be able to support. It's one of the, for those of you who don't know Hangout, it is an online, it's an MMO. It's room-based, it's built with Unity and some other technologies. And one of our mandates from our CEO from the beginning, this is the sort of the blessing and the curse of not having a client, is we don't have any specific tangible features and goals that need to be in place at any time. We have about a 2-week vision at any moment, and we need to be able to move on that 2-week vision constantly. And so we have to be as nimble as possible, and decoupling is really sort of the primary approach. And then writing reusable code means that hopefully as those changes happen, you can keep 60, 70, 80, maybe even 90% of the work that you've done, even as you jettison whole features and whole parts of your product. So, smaller classes. Why smaller classes, and how does that help? First, the name of the class can actually mean something. Right? If it's a giant class, there's no name you can put on it that encompasses all of the things that are in that class. I jokingly, every once in a while, will make a method name that's, add this information and populate this information, but don't do both at once unless it's really necessary. As soon as you're doing that, that's a good sign to you that it's time to take with that method or that class and break it apart. Again, the bigger the class, the less reusable it is. It's just a fact of life. The more lines of code there that's in that class, the likelihood that you can reuse that class diminishes very, very quickly. And also, the less obvious the class is, the less reusable it is. 6 months later, you're looking through piles and piles and piles of files, and you're trying to figure out what these classes do. And if it isn't obvious, you're going to rewrite it rather than reuse it because you can't remember what that one particular class does. So keep it obvious. We have debates in our office about code commenting and what level and how much and how little. But the most basic issue is be really obvious with your naming conventions. And if you can be really obvious, then you're more likely to find that thing again. It's similar in my house. We have a rule about when it's time to throw something away. If you can't put it someplace so that you would ever think to look for it again, throw it away because you'll never find it again anyway, and it might as well be gone out of your life. So if you can't think of a name for a class that would, clue you in as how it would be used next time, you're basically instantly writing something that can't be reused. Interfaces. Just a quick overview. I'm going rather quickly, actually, so there's going to be a lot of time for questions. I hope you have them. Interfaces describe the methods available for calling classes. So instead of saying what exactly you do, you say these are the things I support. I support save, I support load, I support commit, I can support update, those kinds of things. And then how you do it is up to you, and there are going to be lots of different classes that can support that. And so as a calling class, rather than requiring an SVN, for instance, class that can implement SVN, You require anything that supports that interface, and then how they implement that interface is really their problem, and it really boosts encapsulation. Interfaces are originally to deal with the circular reference problem, but they also solve other problems if you use them properly. The other thing with a lot of these things is to keep in mind that any approach, any coding philosophy can be abused, right? So you can write an interface for absolutely everything. When you're going to do anything, you write an interface first, even though you know it's a one-time use, and then your time is taking longer, and you say, hey, Mike told me I had to write an interface for everything. And all of these things are with some thought behind them, right? So is there a possibility that I want to be able to implement more than one way of executing this process? Yes, and it's an interface. So it allows greater flexibility, and it's a good decoupling technique. The other thing about interfaces is it makes testing a lot better. So you can write a test against an interface, and then anything that supposedly is going to support that interface should be able to pass the same tests, right? If I do this, something should happen. If I do this, something should happen. And that's a great way to, now you're reusing your tests as well as your code. And you're getting that bug-free code that is the myth of all project managers. Remove public references. So this is all C# because this is what we use in-house, but if you've gotten used to writing public game object some name or public component some name, get unused to it. It's just going to lead to lots of problems down the road. They also, by definition, anytime you're doing this, you're writing tightly coupled code, because not only does the code require certain other classes to be available, it requires certain other game objects to be available, or certain other components to be available. And you're not being very specific about what functionality that component should have. So if you really need a reference to a component on another game object, it should be at a minimum the specific script that you've added, not component in general. You want to say, I need an instance of a script that has this functionality, so either that's an interface or a specific component. The other thing that's very important here is that, and I talked about our developers about this all the time, the hierarchy in your scene should be completely unrelated to your code. If your code says, I assume that there's a parent to this game object that has a sibling that has a child whose name is Betty, who has a cousin, so the likelihood of you using that code goes to absolute zero. So you really want to remove any reference to the hierarchy from your code wherever possible. There is one exception, which is if your code created that hierarchy. So we have a lot of late-bound tools, we have a lot of managers in our code, so there are whole sections of the hierarchy that were created by us. So one thing is we have references to all of that, so that's the better way to do it. I made this thing, I'll store a reference to it if I need to talk to it again. The other approach is, well, I added all the ones that are children of this grouping node, this grouping game object, so I know I can delete all the things that are children of that grouping object because I made them in the first place. So code-generated hierarchies are okay. You want to try to avoid them wherever possible. Sometimes they just happen. But otherwise, referring to the hierarchy in your code is you should kind of consider it taboo, because it's guaranteed that there is information that your code is going to require that is not kept anywhere in that code. And when you're trying to figure out what made it work last time, you're pretty much never going to figure it out without reading the code line by line, in which case you might as well have just written the code line by line. That's not reuse. Other issues with public references. So they're very hard to debug. So what happened? Oh yeah, there was a public reference in there. Finding public references. Now you're wandering through the inspector looking for, which one of those public references might have been null. They're not found ever when you compile, right? The compiler doesn't care that that game object was null. Whereas, yeah, that's... Also, you've got a new project, you want to use some of the code from the old project. Well, you can't just use the code anymore. Now you need to use the hierarchy that may have been specific to that situation. Now you've got prefabs, you've got asset bundles, you've got export bundles. You're pulling in things, and you're really losing a lot of your ability to quickly and nimbly assemble a new project. And like I said, runtime errors, yuck. You want to avoid runtime errors wherever possible, especially if you're in the web sphere, which Unity is really strong in. Again, also now if you think about the Wii sphere and the iPhone sphere, so these are situations where, again, you don't really have a strong runtime debugger. So you want to move as much of your problems, your code issues, your errors into the compiler time as you possibly can. And I'm going wicked fast, so I should slow down or something. It's coffee. The event model. So the event model is something that's used a lot in ActionScript, and it was the sort of early and rudimentary event model is actually implemented in Unity with things like onStart, onAwake, onGUI. We use a more extensive event model that's implemented by ActionScript 3 and a version of that. Events, if you think about it, are kind of implied interface. I'm expecting a class of this type and only this type. I will wait for classes of this type to start appearing, and I will process classes of this type. So that's a kind of implicit interface, where that event becomes the interface between two classes. They don't know about each other. They only know that one of them generates events of a certain type, and the other one processes events of a certain type. So the general idea is you add a listener for a type of event, which you can think of as, let me know if something happens. That something being the room is fully loaded in our case, or an object is done downloading, or the name of the current user is finally available. And then the message itself is, well, that something happened, you deal with it. I don't know what you were planning on doing with it. That's really your problem. It's really, really good for web-based projects. The reason it's good for web-based projects is multifold. One, most events on the web are asynchronous. Start downloading this, start doing this, get this information, let me know when this is done. So Unity just in 2.5, they announced this morning, right, has load asynchronously, load this asynchronously. What you can end up with is a ton of coroutines everywhere. Everything is a coroutine, everything is yielding on other things. You've got loops all over the place. And the problem with a coroutine is that it has to be in a game object, in a mono behavior, right? Mono behavior has to be on a game object. So once again, now you've got code that has to sit on a game object in order to function. With the event model, you don't have to be on a game object at all. You just sit there listening for an event to happen, and when that event happens, you know it's time to go. You've got your starter gun. So there are a lot fewer yields, a lot fewer loops going on, and frankly, the code can be a little bit easier to debug. This happened, I do this. Sure. Yeah. Mm-hmm. Right, so that's going to happen through either some kind of manager or through an instance event. So you could say, let's say you have a class that loads asset bundles. You could say, I want to make a new instance of this class, and one of its properties is what asset bundle it's going to download and where it should get it from. And then you can say, and I want to add a listener to this particular instance to let me know when it's done. Boom, no more yields. Mm-hmm. Well, the message itself can have the message class can have the image information, right? So you can actually remove. You're not necessarily including references to the object that's passing the message. The message can be fully encapsulated itself. Here's the message. It's got the image data. It's got all the other information you'll need to know about this event. So if you think about ActionScript, ActionScript actually does a lot of what you're talking about, where most of the information about the event is in the target parameter, and you're basically just going back to the thing that fired off the event, and then you're investigating all the properties of that object that fired off the event. The way we tend to do it is, wherever possible, make the message itself an encapsulated class. So here's all the information you're going to need to process this, rather than having pointers to lots of other things. Is that? Yeah. And again, a lot of these issues are going to be on a case-by-case basis. There may be so much logic behind that it needs to be a pointer. Or you can use messages as a way of revealing information. So instead of having something necessarily private or necessarily public, it's actually only accessible through the message. And so I'll let you know when this information is available, and until then, it's not available, because the way you got a reference to that object was through the message. So hands off until I say we're ready to go. And if you think about the web, most web processes are asynchronous. And so it's actually been really good for us to be able to say, to manage all those asynchronous processes. There we go. There's also a term that we've developed in the office called three-state data. And this is something that's true of events. Events are all three-state data. The first, so traditional properties are very simple. They're either null or not null. The question is, what does null mean? So in some cases, null means I'm uninitialized. Some cases it means I've been de-initialized. Some cases it means I'm not ready yet. Some cases it means I will never be ready. That's not really enough information a lot of the times when you have lots of complex processes going on. You want to know, is the information ready yet? Is it now ready, and has it been updated? And so events, if you think of it that way, are a kind of three-state data. Before you receive the event, it's not yet ready. Once you receive an event, it is now ready, and if you get another one, that information has been updated. So you get that three-state information. So like I said, null might be nothing, events are clear, and events don't require a coroutine. So available, unavailable, available, and updated. And this is actually important to remember. We actually ran into some problems. Like I said, any approach you take has its implementation issues. If you are really, you need to be pretty, careful about making sure that you can handle multiple events, right? Anything that gets information via an event should be expect another one coming behind it, because there's a good chance that this is updatable information. So be ready for a second one. If you assume that there's going to be one and only one of a particular type of event, you're kind of asking for trouble, because you don't know who threw that event, and now you've got a second implicit contract around that event. I'm listening for this event, but I only ever want to hear one. Well, if you expect to only hear one, now there's more information that's not in the code. So, an example of an event. So at Hangout.net we use the user change message. This is a really good example of an event. This user change message says who's in the room, a list of all the people who are in the room, which one this user is. So since we've got lots of people running the Unity game at the same time, you need to know each person in the room needs to know in the list of people that are there which one corresponds to me. And it uses that information to figure out what avatar to download, how to customize you, what you're allowed to do, what you're not allowed to do, which set of properties is me. Obviously this can change at any time. Someone could leave the room, they can come back into the room. Anyone but you could theoretically disappear. And it's not necessarily available when Unity starts because of the way we do our networking. When the scene starts up, there isn't a list of people necessarily available. So you need to say, let me know when the list of people is available and I'm going to do something with that information. In our case, the information is actually obtained externally, as is a lot of web information. So we have our server side managing the MMO, and that information comes from there. The other nice thing about the user change message is that it's not dependent on the implementation of how we manage our MMO. We're using one technology today, which I can't necessarily divulge for NDA purposes, but we can chuck that tomorrow, and as long as it produces the same manifest of who's in the room, it really doesn't matter how that manifest got created. So, a couple of rules that we try to stick by with events. Never expose data you received as an event as a property. So in our case, you get a list of users who are in the room. One of them is me. Don't take that information of who is me and make it accessible as a property, because now you're hiding the fact, you're hiding how that information came. You're trying to change three-state data into traditional data. And you can't really do that because it might get updated, and then you're not telling people that they need to update, etc., etc., etc. You're sort of lying about the source of this information. You can take an event, do something to it, and publish another event about it, or even send out that event with some changes to it. But you should never take information that came in an event or came in a message and turn it into something that anyone can access publicly as a property. The second one, as I said, and this is actually really important, so I'm saying it again, be prepared for extra events. You might get the same news twice. That shouldn't be a problem. In our case, it may be one of the users changed one of the properties of their information. This is my rank used to be X, now it's Y. My name used to be X, now it's Y. That information may not affect all of the recipients of that message. Some recipients of that event only care about the names in the room, and they don't care about the ranks, right? They're just displaying a list of who's in the room, and they don't care that the other information changed. But the person dispatching the event doesn't want to know about which parts of the properties you really care about and which you don't. So it's just sending off events whenever it thinks something has changed. And if you're not ready to basically handle a couple of extra events, then you're going to run into some trouble. So you should be able to say, all right, I've gotten this update. I'm going to do my update and ignore any information that hasn't that doesn't affect me. If you really, really need to, you can actually compare. You can keep the last version of the event locally and do a little quick compare and say, has the relevant information changed? No, then I'm not going to do anything. If your action upon an event is really time consuming, you might want to do something like that for speed purposes. If no one should have access to an instance before an event, so an instance or a property, then, like I said, this is a great way to expose it. So until the room is fully loaded, there is no room manager that should be accessed by any of the other properties. Well, if that's the case, then you can pass a reference to that manager out through that event, and that's how people get to it. Or there may be other properties about the room manager. So you have the room manager is available as a singleton, but other properties about the room aren't available until it's done loading. What kind of a room is it? How many people are in it? How big is it? That might be information that you need, but isn't going to be available until this process is complete. And so you're going to expose that information through a message. So our event implementation. We tend to use singleton classes for registering listeners, but that's not a requirement. Like I mentioned earlier, there are plenty of examples where it doesn't have to be a singleton that's firing off events. We have lots of message classes. So this is where we actually differ from ActionScript, from those of you familiar with it, where ActionScript has the event as basically a string, and then the event type as a string and the event as a class. We combine that into one, and then we have lots and lots and lots of different types of classes. The message is a type, and it contains the data. So again, unlike ActionScript, we combine them together, and it contains all the information that you might need to know about that event. We use a function to register listeners that's generic, and that lets us, again, get more compile time errors. If you add a listener that doesn't match the signature, it isn't waiting for the specific type of message that it's going to get, you'll get a compiler error. Yay. Those of you who've ever used ActionScript, you get a runtime error if you're listening for the wrong type of event. Boo. So now we've got compile time errors, yay, and runtime silence. I guess that's better than a runtime error. It's certainly going to cause fewer crashes, but it's the better of the situations we have to deal with until we have runtime step debuggers. Another last-minute thing that we discovered pretty recently, once we started late binding a lot of our objects, is you have to remove listeners on disable. So the on enable and on disable are events that Unity puts on mono behaviors specifically. If you have, let's say you're and I'll show you a code example in a minute, but if you're a late bound thing and you say, hey, I want to know whenever users come or enter or leave the room, because I'm a particular type of display of the users that looks like a jukebox, and records appear for every user. You appear in the room and you say, hey, let me know of any user change message, and then the user says, okay, I don't want that jukebox anymore, and tries to chuck it. Well, the class that sends out the messages still has a reference to that game object, and so the game object will not be destroyed and can't be destroyed because something still has a reference to it. So even with that nice function that Joe showed this morning, which was, what was it? Destroy unused objects. Garbage collect unused objects. Thank you very much. Those objects will not be garbage collected until you tell the manager, all right, I'm out of here, remove the listener. And the place we discovered to put that's most effective is on disable. If you scene switch, on disable is called. If you destroy an object, on disable is called before it gets destroyed. So it sort of covers all your bases. So, code example. We add listeners on awake, and we send messages on start. So the term we use is add listener and route. So the room current is a singleton. It's a lot like camera current. And this basically says, if there's a user change message, call the method called getLocalAvatar that's in this class. On start, I might want to route a new Unity init message. This is a message that we send some other things to say, I'm just awake enough to start getting more kinds of information. On disable, we use the remove listener so that there aren't dangling references to this object if we ever switch scenes or get destroyed. And then we have the method that actually processes the information. In this case, it gets the manifest of all the users in the room and says, okay, which one is mine? And let's start loading that one. And the nice thing about this is because user change message, I can't really point here. Because user change message is in the function signature here, we'll actually get a compile time error if that doesn't match. Again, we beat ActionScript 3.0. They'll just tell you when you hit play and things start going kablooey. So this is our code example. There are lots of ways of abusing this. The first way of abusing this is there's certain times when only you want to know something. And so rather than saying, okay, I'm going to pass a delegate to some function and have them let me know specifically when something's available, everybody starts sending messages about everything everywhere. Another way of abusing this is that not all messages are for everybody. So there's no reason why you can't have more than one object in the room that is sending messages. You don't have to route them all through a central location. You can route them through specific instance objects or specific objects that are managing certain types of tasks. So we got to a place where, some of our new developers like, oh, everything's a message, and messages were flying all over the place. And a lot of times it was literally just, it really should have just been a function call or an interface call. They just went to a message because they learned about messages, and messages are fun. I'm trying to think of other backlashes from the messaging model, but it's really actually suited us very well. The three-state data really represents asynchronous processes and web processes really, really well for us, and it keeps bad things from happening. But like I said, as with anything else, it can be abused terribly and lead to bad things that need to be fixed. So that's all I got. That was half an hour instead of 40 minutes. So I went a little fast. Are there questions? Start at the bottom.
Yes, if I want to create a manager, I want to know what's the best way to create it in Unity, because if it's a singleton, because imagine that we need a manager that saves updates and start. If we create a singleton, perhaps other class gets a reference, but it's not created yet because the start method is not called.
Right. That's actually something what we talk about a lot in our office is having multiple entry points. And so we were actually just talking, Matt Bitterelli's back there, he's one of our developers, about having a manager, right? So you have one manager that gets that first one, and it spawns off all the other managers. That you only end up with one singleton, and then the other ones become instances that you access through that singleton. And that way you have one entry point, and you know that it started before anything else started. We use the room as our sort of primary singleton, and then we use the messaging to say, okay, have you gotten what you need to do? I'll wait until you get in a init. For those of you, again, familiar with ActionScript, there is it's an event that basically says the component's been laid out, and you actually can't access anything that's an on-screen element until it's laid out. So all you do in the constructor is say, well, when you're done being laid out, call this, because that's when the real work starts to happen. So it may be that in your start or in your awake for most of your classes, all they do is add a listener and then wait for that sort of bootstrap routine to be complete, and then they go, and that's a way of sort of reinforcing that.
Yeah, I got sort of a practical question regarding the decoupling stuff.
Yeah.
Because we've been sort of trying to live by kind of the same sort of decoupling ideals, less successfully, I think, because I find that there's two sort of dynamics that in game design that sort of work against that. And one of them is that we're trying to do, we're always doing sort of very iterative development because you don't know what's going to be fun. So
Sure.
You sort of always have to change your game design if you want to end up with something that's actually fun, That's the one thing, and the other thing is like constant deadlines, which you're probably familiar with.
Yes.
So I'm just wondering sort of how do you kind of, given those two dynamics, how do you sort of manage to stick with that idea?
Well, so the things that should be public, and this is sort of going, I think it's actually a talk that's going to be later today or tomorrow, is the How to Do Physics Right. And he gave that talk last year at Unite, and he basically says, expose through the inspector the important variables that actually adjust gameplay. So that's actually a place where you want to use the inspector. That's the right way to use the inspector. Is, you've got your developers and you've got some people who want to play it and tweak it and play it and tweak it and get that iteration going. The thing is just, and it is a balance, and there isn't really an answer. is, does this affect gameplay, or am I just kind of like, does one class really want access to this, other thing? The other point to make is that, and this is a discussion we have in the office all the time, you're going to pay for it one way or another. You're going to pay for that speed one way or another. You either pay for it on the back end, so you want to be really, really iterative, and then you figure out what you want to do, and you sort of have to now reinforce and build out that structure. So you either pay for it then by, okay, we did the iterative thing, now we have to go back and do it right. Or you pay for it up front by saying, well, let's take a few minutes in the beginning. Are there interfaces we need to do here? Is there a structure or a framework or a manager that's going to help enable iteration early on, and you sort of pay for it up front. And that's a debate that you sort of are going to have between the developers and the project managers again and again and again. And there's no real good answer to that.
There's also another factor as well, is how much scalability do you actually need,
Right.
Because you reach a point where your product is just complete, it doesn't need to be developed anymore.
Right. Well, we personally are never going to reach that point because of the way that so that model that Phil talked about this morning, that is our model, right? We don't ever wave goodbye to the truck. We're coming out with a new release every 2 weeks for the rest of our corporate lives. So we don't ever get that opportunity. But that refers to something I've always called the horse look. So horses can have one eye look in different directions. And as a developer, you need to be looking straight down and far ahead at the same time and find that kind of middle ground. If you're looking straight down, you're going to stumble over things. You're not going to think about what's coming down the pipe. But if you're looking far, far out into the future, you're never going to ship. So what is that middle place? And actually, we found that decoupling can actually help that strategy, because you can say, okay, GUI, you go do your thing. I'm going to do the underlying structure. If it turns out that the designer hates the GUI, but they like the gameplay, then we're going to redo the GUI, and the gameplay doesn't actually change. So decoupling can actually help find that middle ground, but it does require a little bit of understanding of everybody involved. It says let's pay for this up front because it's going to cost us a lot later. Yeah.
Just a remark. You were talking about how your delegates would prevent garbage collection.
Yeah.
And there's an article on the code project about using weak references to avoid this kind of stuff.
Yeah.
So I thought you might want to check that out.
Yeah, thank you. So
and I also had questions.
Yeah.
Why don't you use the .NET event model?
It didn't cross our minds, frankly, at that time. There's a whole structure to that. The other thing is a lot of the .NET events are tied to whole .NET packages, and the more packages you start to install, the bigger your game starts to get, and some of those packages are enormous, so you kind of have to be careful about, you have to be picky and choosy if you're web-based.
No, but even not reusing their own events, but why don't you just declare an event instead of add a listener and stuff?
Research. That's it. So that event.
You think your way is better?
Not necessarily. No, I think it's just another way. But it's really about using an event model as opposed to tightly coupling. So you can use entirely the .NET events and go that way.
You think that would work?
Yeah, absolutely. I mean, it's really the idea of an event more than anything else.
So how do you feel about send message?
So the problem with the Unity send message. The problem with the Unity send message is it's through a game object. So that inherently says I need to know the name of the game object, or I need to do a game object.find, or I need to have a public reference to a game object. So that was our goal, was to get rid of those things. Game object.find, if you ask anybody on the Unity staff, is the slowest function in the entire API. So we actually have a test. If we find game object.find in your code, you go to the back of the class for at least an hour. And it's a real issue. So send messages, it basically doesn't really allow you to truly decouple. It's nice. It's sort of like the first. How can I put this? The nice thing about Unity is that it has this smooth learning curve. You can get in there and start doing stuff really, really quickly. So send messages like, okay, I'm just starting to learn about this idea of sending data through an event, but you're still using that game object reference. So the next step is to stop using send message and use the same type of general structure without having to have a reference to a particular game object, or heaven forbid to game object.find. And then somebody accidentally changed the name of an object in your hierarchy and everything breaks.
Did you still find cases where you need to use it, or?
We don't. I haven't found a case where we need to use it.
I'm trying to get rid of it, so I was wondering.
It is possible to completely get rid of send message. Yeah. Yeah. Any other questions? Yeah.
I'm pretty new to UFB, but which tools do you use to program the code? The Unitron or?
No, we use TextMate, and then we have we've added our own TextMate bundle, which is very easy to do, and I think it's actually Chris Mortensen is on the forums a lot. It goes by More Talk. I think he's actually shared our TextMate bundle, which TextMate's what, like $30 or $50. I'm actually really excited about the Windows version, not because I love Windows. I've actually come to hate Windows, but Visual Studio is a great tool, and I'm really looking forward to actually having Visual Studio as the yeah, and the host share, it takes up a lot of CPU, and then you're dragging down your performance. You're not finding out what's actually happening, but it's possible. And actually, they're not here anymore because they left. But the guys from he's going to do the physics talk. They do all their development with Visual Studio. And if you notice, as soon as a new Unity release comes out, I forget who does it, but somebody instantly makes the.
That's me.
Is it you?
Yeah.
Okay. Instantly says, okay, here's the Visual Studio DLL, so you can actually do everything in Visual Studio.
Yeah. Thank you for that.
Yeah.
You're welcome. So, many people are using Visual Studio. I've always been curious.
Yeah. I do.
Not that many.
So, any other? Yeah.
Do you have like general recommendation when to use plain classes versus mono behaviors? Because when I started out, I wanted to do everything with plain classes, and I really hit the wall immediately with that approach. And then I kind of found it quite intriguing to use mono behaviors and like building my structures with prefabs.
Yeah, I think that's sort of like 200 level Unity coding, maybe like 300 level Unity coding. And then you get to the 400, 500 like graduate level Unity coding, which we're actually trying to switch to ourselves, which is there is no hierarchy until the scene starts, and actually all the components get added dynamically. So rather than having a built-in hierarchy, because everything we do is late bound and basically specific to this user. So rather than artists having to drag specific components onto something that says, oh, this is a colorizable chair, they check off a box that goes into the database that says, oh, when you download this, apply this component onto it dynamically. And that's our hope of removing that next level of error, which is, oh, the artist put the wrong component on that object. They didn't know we switched to component B from component A. Mono behaviors are heavy. I mean, there's a lot of overhead to a mono behavior. I don't know if it's technical overhead in terms of actual drag on your performance, but there's a lot of things that it's doing. So our approach is don't use a mono behavior until the first moment that you have to. And for us, that usually is the first moment we have to is on GUI. It's like, oh, I wish I could do on GUI without a mono behavior, but you can't. And again, mono behavior. It's mono behavior, and this is the debate we have in the office. Is that thing that enables Unity to be really easy for entry-level developers, and then you get to the graduate level, sort of this thing that's dragging you back because you want to have a more complex code structure. You want to have sort of different entry points in the inheritance tree, and you're really only given one, which is the mono behavior. So I'm this is a guess. They're not in. There's no one from Unity's. Okay, this is my guess of what's going to happen in a couple of years with Unity. The same thing that happened with ActionScript. They had the movie class, which was this like huge, bloated, has a timeline, has all these things that most people stop using. And what they introduced was, okay, there's the movie class, or you can inherit from Sprite, or you can inherit from, and they basically introduced the other levels of that inheritance tree. And you can basically pull out the point that you want to inherit from that has the capabilities that you need, rather than having to go all the way down. But, products have to develop over time. You can't think of everything in the first week. Anything else? Yeah, sure.
What are you using for networking? Are you using any of the Unity?
We are not, and I'll tell you one reason why we're not, is as chief architect, we are a second through the door type of company. We want to see someone else rush through the door and see if they get shot. And so I'm still waiting for someone else to run through the door, do a huge networking project using the built-in Unity stuff, and show me that it's sustainable and workable, and that it's going to come out fine. And as soon as they do, I'll probably walk in behind them and join the party. The other reason we don't use that particular model is with the structure of our MMO, other people can be in your room without you, and their model sort of assumes that somebody is going to be the host. So either you have Unity running on some server somewhere in kind of a headless mode that people are joining and dropping out of, or someone is the host and they can never leave, or you have to have some very complex process where you say, okay, I'm leaving now, someone has to take over as hosts for all of the processes, and all of the users are basically switching their connection over. And so that's really the two reasons. Is we want to see someone else. We want to see if someone else gets shot, and we need to be able to have that master. We don't really have a master-slave approach. We have a peer-to-peer approach. That it? Okay. Well, thank you very much. My email is there if you have any questions, and look forward to seeing you guys around. And we're hiring. Oh yeah, forgot to say that.